All right. So we got trig equations day 2. So I broke 7.3 up into 2 parts, partly because some of the stuff that you need to do, like on number 4 and 5 and 6, requires you to have learned your trig identities. So I don't know why this was before 7.4, but it was. Anyways, yeah, so that's why I took a break, did 7.4, and then now we're doing 7.3, day 2. So today we are going to solve some trig equations in quadratic form. I'm pretty sure that's a typo, so I apologize. Goal number 2, we're going to solve trig equations using identities. So again, sine squared plus cosine squared equals 1. We should know sine over cosine is tangent, stuff like that. Goal number 3, we're going to solve trig equations, linear in sine and cosine. I'll explain what that means here in a sec. And then goal number 4, solve trig equations using a graphing utility. You don't really need that today. So at any point you need to throw one of these in your calculator, you could. But yeah, I'm just going to show you how to do it by hand. So when we're solving these trig equations, guys, we're just finding answers from 0 to 2 pi. Majority of the time, it's going to be 4 or less answers. Okay, so there's 4 quadrants. Usually, again, there's 4 answers there or less. So as we take a look, answers are going to be in radians, 0 to 2 pi. Again, it's not inclusive on 2 pi. So again, there's no equal sign there. So do not include 2 pi. Okay, just like what we did in 7.3. Day 1, we're going to include 2 pi or 360. Just in case you didn't know, 360 is 2 pi. So as I take a look at example 1, I've got 2 sine squared plus sine equals 0. Okay. Now that freaks some people out, but that's the same thing as if I just remove the signs and put x's. So I have 2x squared plus x equals 0. How would you solve that quadratic back in the day in Algebra 1, Algebra 2, now in Trig, pre-calc? How would you solve this guy? I've got my stuff equal to 0. Right? Factor out next, GCF, right? So look for a GCF here. Okay, so we would take out an x, and that leaves me with 2x plus 1 equals 0. Well, exact same idea, take out a sine. And then we would get 2 sine of theta plus 1, and that equals 0. Okay. So far, so good? Pass, no pass?
No pass. I'll do the text that are reading my Chromebook.
Okay, thanks. So as I take a look, we would set each one of these equal to 0 and solve for x. Exact same idea. We're going to take the sines and solve for sine. Okay, so I've got sine of theta equals 0. And then we have this guy, 2 sine of theta plus 1 equals 0. That's just called the zero product property, where I set each product equal to 0 and solve, because if this times this is 0, either this one equals 0 or this one has to equal 0. Okay, so I can go ahead and subtract 1. And I get 2 sine of theta equals negative 1. A lot of you guys can just do that part in your head, which is fine. And we get sine of theta equals negative 1/2. Okay, so are we done? No, we got to find theta now. We got to find the angle that allows me to solve this. Okay, so I've got regular sine of theta equals 0. Again, anytime I see 0, 1, or negative 1, I'm thinking circle, quadrantal circle, not triangles. Okay, so let's go back over our quadrantal circle. So we have that for our notes. The numbers that I use, at 0 degrees, I have 0, 1, 0. At 90 degrees, I go IOU, 1, 0, U. And then if you know these two, then you know these two. Just do the opposite. 0, negative 1, 0. And if that's IOU, down here is negative IOU. And again, this is in terms of SOHCAHTOA, 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 and SOHCAHTOA. All right, we are trying to find out, where is sine 0? Where's the first number listed 0? And you guys would say where? 0 degrees, not 360. Don't include 360. So this guy. So theta is at 0 degrees, which we know is 0 radians. And then also where? Where is sine 0? What do you guys got right here? You get 0 right there. So that's 180 degrees, and we should be able to convert that into radians, right? That's what, pi? So far, so good. Any questions so far? All right, are we done? No, we still got to solve this one. Okay, so if I have sine of theta equals -1/2, first off, this is regular sine, so it works in all 4 quadrants. All students take calculus. And we want to know, where is sine negative? Where are our 2 triangles going to be? A, S, T, or C? Where is that opposite leg negative? What do you guys get? All students take calculus.
Bottom one, right?
The bottom one's right. Yeah, T and C. Quadrants 3 and 4 is where that opposite leg is below the x-axis, which makes it negative. So as I draw this guy real quick in quadrant number 3, working from this angle, this is again O and H. This is opposite hypotenuse. That's -1 and 2. Well, I have enough to figure out what this angle is. What's across from -1? That's 30 degrees. Now, some of you guys on the quiz on Monday were typing it in as pi over 6 is your answer. It's not pi over 6 because I want the big angle. I want this guy from 0 all the way to this line. That's 30 degrees past 180. So if I take a look, 30 plus 180, that's what, 210 degrees. Okay, so that's 210. And go ahead and convert that, divide by 180, put a pi on top, or use your little pinwheel from 6 2 notes. And I've got 7 pi over 6. You guys okay with that? I'm assuming we know how to convert degrees to radians now. I don't need to show that, right? Right. All right, sine is also negative in quadrant 4. So basically make the exact same triangle. 90 degrees with the x-axis. This is opposite, that's hypotenuse, that's -1, that's 2, and that's still a 30-degree angle. But I want the big angle going all the way around, okay? 30 degrees short of 360. So that's 330 degrees. And then go ahead and divide by 180, put a pi on top, put that thing in radians, and what is that? What is that, 11 pi over 6? So I get my 4 answers there. Not always going to have 4, but in this case we do. I've got 0 pi, 7 pi over 6, and 11 pi over 6. So my solutions there. Okay, you probably won't find more than 4. So it's 4 or less. Could be 3, could be 2, could be 1. All right. Do we have any questions on that one? So again, we had a little bit of sine of theta equals 0, and then you have to solve this one. Okay, so basically we're dealing with quadratics now. Okay, we know how to factor quadratics. We're going to be good to go. All right, let's take a look at example 2 here. Any questions on 1 before I move on? All right, sometimes they're hard like number 1, and sometimes they're super easy like number 2. So as I take a look, I've got cosine squared equals 1. Well, that's like x squared equals 1. How would you solve something like this and then apply it to this? Yeah, you can just square root both sides. All right. So I'm going to go ahead and square root both sides. And I get cosine of theta equals the square root of 1 is 1. But Mr. Gotch always says, what's that? Rationalize it? No, don't need to rationalize it. Don't forget the plus or minus sign. So anytime you square root both sides, make sure you use the plus or minus sign. Okay, because we could have subtracted this over and then factored, and there'd been 2 answers there. It'd be x squared minus 1, and that's x plus 1, x minus 1. All right, so don't forget the plus or minus. Okay, again, anytime you have sine or cosine equals 0, 1, or -1, we're thinking quadrantal circle, just like we did over here. All right, so again, let me draw that quadrantal circle for your notes. This is 0, 1, 0, IOU, 0, negative 1, 0, negative IOU. Again, those in terms of SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. This will be the last time I draw all of them. We're looking to see where is cosine, the middle number, 1 and negative 1. Where do you guys see that? Where is cosine 1 and negative 1? What degrees? Right here? Is that what you're saying, Raman? Right there? Where else, Raman? At pi, right there. So 0 and 180 degrees, right? Or 0 and pi, which is what my math lab wants. Okay. So again, we're looking to see where cosine is 1 and negative 1. That happens at your quadrantals of 0 and 180. Do not include 2 pi. You'll be wrong. Okay. It's all the way up to like 359.9999 degrees. Do not include 360 or 2 pi. All right, all right. Do we have any questions with that one? All right. Well, sometimes they already have it ready to go for you. So when you look at example number 3, this has been factored already. So sometimes your initial thought might be, hey, let's go ahead and FOIL this thing. Don't FOIL it. The whole idea is to get all of our stuff equal to 0, get our stuff on one side equal to 0 so that we can factor. Well, I have it equal to 0, and it's been factored for me. So this thing is ready to go. So I can go ahead and take the cotangent of theta plus 1 and set that equal to 0 and solve it. And a lot of you guys can go right to this step, which I do. I go with cotangent of theta equals negative 1, and then set this one. Cosecant of theta minus 1 equals 0. Let's go ahead and solve that. I usually go right to this step, just like if this was an x value. So this thing's ready to be solved. Okay? So let's find theta. What makes theta for cotangent negative 1? We've talked about this in the past. Remember, this is A over O. And what type of triangle? 30, 60, 90, 45, 45, 90, whereas A and O been completely reduced because they're exactly the same, but all I'm left with now is a 1 or negative 1. A 45, 45, 90, right? Where opposite and adjacent are exactly the same. Okay, so the idea is this is a negative root 2 and a root 2. So anytime you see tangent or cotangent and you see plus or minus 1, I want you thinking 45, 45, 90 triangle. Okay? All right, so where do I draw this thing? All students take calculus. Okay? Tangent and cotangents are buddies. So if tangent's negative, that means cotangent's negative and vice versa. So if I have cotangent is negative 1 or negative root 2 over root 2, I got to know where tangent is negative. Whereas the opposite leg or adjacent leg negative and the other one's positive. Where's tangent negative? Well, I know where it's positive. They're all positive in 1 and tangent's positive in 3. So that means S and C, quadrants 2 and 4, I'm going to have a positive opposite or adjacent leg, and the other one's the opposite, negative. So I'm going to draw, any questions why I'm going to draw these in quadrant 2 and 4? All right, so quadrant 2. I know this is root 2, and that's a negative root 2 for opposite and adjacent. And then that is a 45-degree angle. Now, again, on the quiz, a lot of you guys were putting that the answer was 45 degrees. And unfortunately, that's not right, because in quadrant 2, it's obtuse. So again, 180 minus 45 is 135 degrees. So go ahead and convert that. What's 135, y'all? Shout it out. Use your pinwheel. 135. Drew, you got it?
3.4.
Boom. Okay, just take 135, divide by 180, math frac that thing, or look at your pinwheel and just know these by heart. Okay. And then I'm going to go ahead and do quadrant number 4 because that's where else it's negative. In this case, that's a negative root 2 for the adjacent leg. Opposite is root 2. That's still 45 degrees. But we want the big angle. We're not going down. It's not negative pi over 4. We're going counterclockwise. So again, this thing is somewhere between 270 and 360. We'll go ahead and take 360 and minus 45. And that's what, 315 degrees, right? So we get 315. Converted is 7 pi over 4. So far, so good. Good stuff. People at home, do you have any questions? The only person I see is Zach. Everybody else is sleeping, I think. Oh, man. All right. So we still got to do this one. We still got to do cosecant of theta. Okay, who's his buddy? Cosecant's buddy. Sine. So this is really the sine of theta equals 1. Okay, and if I multiply both sides by sine, that means that sine of theta also has to be 1. Okay, so if cosecant is 1, sine has to be 1 because cosecant is 1 over sine. So 1 over 1 is 1. Okay, and then we go back. Well, again, if sine or cosine is 0, 1, or negative 1, we're looking at quadrantals. Okay, so when I take a look, I go up here, right? Where's sine 1? Up here at 90 degrees, so Toa. So this one right here, quadrantal angle, IOU, that's 90 degrees, which is pi over 2. And there's my 3 answers, okay? I don't want down here at 3 pi over 2 because that sine is negative 1. So sine is negative IOU down there. You don't want that. We just want positive 1. And that happens right there at IOU, which is, again, 90 degrees, which is pi over 2. All right, do we have any questions? Let's come back to number 4. Okay. Let's come back to number 4. I want to do number 6 before we do 4. Okay, if I look at my goals again, goal number 3 said solve trig equations, linear in sine and cosine. This is an example of it being linear in sine and cosine, where I don't have a squared sine or a squared cosine. It's just, in this case, sine minus cosine. Okay, so it's not squared. Suggestions on how to solve something like this. Sine minus cosine equals 0. There's no factoring that's needed because it's not squared. Any ideas? Just throw out some ideas. What do you want to try to do here? Add the cosine over, so separate them. Perfect. This is just called brainstorming. I'm kind of helping you along here. So now I have the sine of theta equals cosine. Okay. Now some of you guys might be able to solve that and figure out, hey, what trig ratios, what quadrants would be where sine is equal to cosine? Okay, so you could try to solve that. Or a little trick is now once we have sine equals cosine, I can divide this guy over. And now do you guys know what sine divided by cosine is? What's that guy turn into? What's that? That's tangent. That's trig identity. Sine over cosine we should know is tangent. And then over here, cosine divided by cosine turns into 1. Well, again, tangent is TOA. And anytime you see 1 or -1 for tangent or cotangent, that means opposite and adjacent are the same, which we just talked about. That's root 2 over root 2 for tangent. All students take calculus. It's a positive 1. It's a positive root 2 over root 2. So again, tangent is positive in A and T. All 3 trig ratios, SOHCAHTOA, TOA, and positive in 1. And only tangent of SOHCAHTOA, TOA is positive in 3. Okay? So as I take a look, I draw my little triangles there. Some of you guys know the answers already, which is awesome. So we got root 2's. So that means that's a 45-degree angle. So that one is 45 degrees, which is pi over 4. And now the other one is in quadrant 3. That's a negative root 2, a negative root 2. That's still 45, but I want the big angle. That's 45 degrees past 180. So what's 45 plus 180? How many degrees is that guy? 225. And go ahead and convert that, divide by 180, put a pi on top, and I believe, I'm getting old, I'm pretty sure that's 5 pi over 4. Okay. 45s are always the odd pi's over 4s. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Always the odd pi's. 1, 3, 5, and 7. Yeah, buddy. So that one's done. So that's an example of where we have a linear sine and cosine. Okay. Do what I think it might have been Raman suggested, get sine equal to cosine, and then you can divide it over and solve it. All right, all right. I'm going back to 4 now. Okay, this is probably the hardest one you would see. Quiz or test, I would probably give you number 1. Question like number 1, I think, is something that you should be able to do. Question number 4 is a little bit tougher, but not terrible. As I take a look, I've got sine squared minus cosine squared equals 1 plus cosine. Okay. When I see something like this, let me use a little sticky note here. When I see a bunch of sines, one sine with a bunch of cosines, mathematically, this is what I'm thinking. I'm thinking I've got a y squared minus an x squared equals 1 plus x. Okay? This is what I'm thinking. There is no way for me to solve this equation because I got a bunch of x's and then this little y here that's messing things up. Okay? So we got to get rid of this y. Or in our case, we got to get rid of this sine squared. Okay, I can't solve an equation that has 2 variables to it, right? Does that make sense? So we got to go ahead and solve this thing for just one of them. Okay, so we got to get rid of this. Okay, well, the good thing is I have a formula. Y squared plus x squared is equal to 1. If I had an additional equation off to the side, then I could use some substitution. Well, we have that. We learned in 7-4 back in the day, back on Friday, we had practice on it yesterday, we learned that sine squared plus cosine squared is equal to 1. Or at least we should have. Okay, this is one of your Pythagorean identities. So if I start seeing squared terms, I'm starting to say, hey, can I use some substitution here? Okay, so the idea is I have sine squared of theta plus cosine squared of theta equals 1. And I want to get rid of this sine squared, this guy right here. This guy's out of place. So this is what I'm going to do. I'm going to subtract cosine squared over, and I've got 1 minus cosine squared. You guys agree that this now can be cut and pasted right there? So I'm going to replace this with 1 minus cosine squared. And now I'm going to write everything else here in blue. So I've still got a negative cosine squared of theta equals 1 plus cosine of theta. So now I have everything in the same terms, and everything in terms of cosine. Or if you're thinking algebraically, everything in terms of x, right? Any questions of what I'm doing right now? All I've done is substitution. I know sine squared plus cosine squared is equal to 1, so if I move this cosine over, I can take that now and substitute that in. All right, well now it's a quadratic, right? Get all your stuff equal to 0. So I'm going to go ahead and subtract the 1 over. And those actually cancel on both sides, which is awesome. And now I have negative cosine squared minus cosine squared. That ends up to be negative 2 cosine squared. And that equals just cosine. So far, so good? Well, I want to, again, I have a quadratic. I have like a squared term here. I want to get my stuff equal to 0. I want to get them on the same side. The idea, again, is this is like negative x squared equals x. Right? We want to get this guy over or this guy over so I can do some factoring and solving. Okay, so you could do either. You could add this, subtract this one over, or add this one over. When I'm factoring, I like having my square term positive. So I would probably add this guy over. That's just me. I like to factor where my cosine squared or x squared is a positive value. Now again, these are unlike terms. One's a cosine squared, one's a cosine. I got to leave them separate. Okay. So now this is like I got 0 equals 2x squared plus x. Now I can go ahead and take out that GCF. This is just like example number 1 now. Okay, so take out that cosine. And that leaves me with 2 cosine of theta and then plus 1. That's all equal to 0. Zero product property says if this times this is equal to 0, then set both of them equal to 0. And then I'm going to set this equal to 0, and I'm going to solve it as I'm going. I'm going to subtract the 1 over and divide by 2, and I get negative 1/2. Are you guys okay with that? And then we got to solve for theta real quick. Nice thing is this one, I just did this circle over here, the quadrantal. I have IOU, and I'm going to add in over here. This is negative IOU. So that theta is 90 degrees up here for cosine. Again, SOHCAHTOA, SOHCAHTOA. And then also down here at 270. So that answer there is pi over 2. And 270 is 3 pi over 2. So that one's pretty much done. And the last one I got to do is cosine of theta is negative 1/2. All right, so all students take calculus. Where is cosine negative? Left or right side? The left side right here. So this is where it's positive, A and C, so cosine is negative in S and T. So you can draw those guys real quick. Quadrant number 2, this is negative 1, that's 2, that's a √3 then, using Pythagoras, you know your Pythagorean triples. And then this reference angle is 60. And if you put pi over 3 as your answer, you're not in the right quadrant. I want the big angle in quadrant 2. It's obtuse in quadrant 2. So if I take 60 away from 180, that's 120. Okay, so 120 degrees, which is 2 pi over 3. So again, that's 2 pi over 3 there. Okay, and then we're finishing up before we leave. Last one, quadrant number 3. That's still -1. That's a √3 negative. That's still 60. But I want the big angle. Just add 60 to 180, and that's 240 degrees. So sorry, I'm writing kind of small. I'm running out of room. 240 is 4 pi over 3. And there we go. Okay. So we've got 90, 270, 120, and 240. That's pi over 2, 3 pi over 2, 2 pi over 3, and 4 pi over 3. Ladies and gentlemen, that's all I have for today. Give 7-3 day 2 a shot and see how that goes, ladies and gentlemen. You guys have a great day. We'll see you later.